Hello everyone. This is the fourth chapter, Measure of Central Tendency. In that, second topic is median. We studied about mean, and now second is the median. What is the median? Okay. See, if a frequency distribution include open-end classes, all of you know what is open-end classes, 10 and above. Okay. Below 30, these are open end classes. We studied in a data condensation. Okay, these are open end classes. Open end classes means what? One of the limit is not specified. Here upper limit is not specified, here lower limit is not specified. We called it as the open end classes. Okay, if the frequency distribution include open end class, mean does not exist. Okay, it so in order to overcome this drawback, the measure of central tendency include median and mode. Okay, median and mode. In this case we can't find the mean. Okay, so in order to overcome this drawback, central tendency introduced the two things, median and mode. One more thing, arithmetic mean cannot be calculated for the qualitative observation like beauty, debating skill, honesty, blindness. Okay, these are the attributes. Okay, so arithmetic mean can't be applied to the qualitative data. So these two terms introduced for the qualitative data. See, what is the definition of median? Okay, median is the value of middlemost observation in the data. Okay, it is the value, middlemost value. But data when observation arranged in a increasing or decreasing order. Okay, if observations are suppose 2, 5, 3, 9, 2, sorry, I write here 4. Okay, these are the observation. What is the median? Okay, middlemost value. But before that we have to arrange this data increasing or decreasing order. See, 2, 3, 4, 5, 9. Okay, so what is the median? 4 is the median. Middlemost value is the median. Okay, got it? It is very simple. See, for the finding median, there are two cases. Okay, see, case 1 for ungrouped data. Case 1 for ungrouped data. Ungrouped data means what? Only observation. Only observation, no frequency is there, only observations are there. Okay, so ungrouped data, only observations are there. See, n, small n means what? Number of observation. Same in a we studied in a mean also. See, ungrouped data means what? Only observations. Okay, n is the number of observation. N is the number of observation if n is odd. Okay, then there is only one middlemost observation. Okay, which is n plus 1 divided by 2th observation. Okay, see, we'll see using example. See, using example, this is the data, ungrouped data. Why we called it as a ungrouped data? Because there are only observations are there, frequency is not there. Okay, so only observations. How many observations? 1, 2, 3, 4, 5, 6, 7. So n is what? 7. If n is odd, okay, if n is odd, 7 is odd number. Okay, what is the formula for median? See, first we have to arrange this number in increasing or decreasing order. Okay, suppose, see, 35, again 35, 36, 37, then 38, then 39 and 40. Okay, these are the number. Okay, see, If n is odd, then n plus 1 divided by 2th observation is the median. Okay, see, n is what? 7. 7 plus 1 divided by 2 means 8 by 2. Okay, 8 by 2 means 4th. Okay, 4th observation. 4th observation is the median. 1, 2, 3, 4th. Okay, this is my median. Okay, 4th observation is the median. Middlemost value by definition is the median. See, this is 37 is the middlemost value of these observations. Okay, so 37 is the answer. Got it? For the odd number. Okay, next is for the same case. Okay, ungrouped data. If data is given and the n is number of observation, n is even number. Okay, then there are two middlemost observation which are n by 2 and n by 2 plus 1. Okay, so how to find the median? Median is equals to n by 2, n by 2 observation plus n by 2 plus 1th observation divided by 2. Okay, if n is even. Okay, we'll see by example. See, this is my example. Okay, these are observations, ungrouped data, only observations are there. First, arrange these observation in ascending or descending order or increasing or decreasing order. So 3 0 2 0 right here, 3 0 2 0 comma 3 2 5 0, then 3 6 0 0, then 3 8 3 0, then 4 0 0, then 4 1 2 0, 4 1 2 0. Okay, see, what is the formula? N by 2. See, 1 2 3 4 5 6. Okay, small n is the 6. 6 is the even number. For even number, formula is nth by 2 observation plus n by 2 plus 1th observation divided by 2. So n is 6. Okay, 6 by 2 is 3. 1 2 3, this observation. Okay, 3. N by 6 by 2 3. 3 plus 1 4, 4th observation. Okay, so 3 6 0 0 means n by 2th observation plus 3 8 3 0 4th observation divided by 2. Okay, so it is 3 7 1 5. Okay, this is a median for the even. Okay, understood? Hello everyone, this is the measures of central tendency chapter 4. Okay, now we are going to see the median for continuous frequency distribution. Okay, and one more thing is, please, it's a request to you all, my viewers and my dear student, please subscribe and share. Many of viewers only watch my channel. See, once you subscribe my channel now, whenever I will upload the video, you will get the notification. So please, request you all, please subscribe my channel. Okay, now we are going to see the median for continuous frequency distribution. For that, there are 4 steps. Okay, what is the first step? First step is obtain the class boundaries. All of you know how to obtain the class boundaries. Okay, subscribe 1 by 2 means 0 0.5 in from lower limit and add 0 0.5 to the upper limit. Okay, so we get the class boundaries. Okay, then LCF start from LCF means what? It is the less than cumulative frequency. Okay, we already studied in the data condensation LCF and class boundaries. Okay, next is the locate median class. We have to locate the median class. Okay, what is the strategy for that? Where the n by 2 observation falls. Okay, Means what? In other words, LCF less than cumulative frequency is equal to or exceed n by 2 for the first time. Okay, that is our median class. Okay, then apply the formula. What is the formula? See, this is the important formula. L plus n by 2 minus CF upon F into H. Okay, where see, L is the lower boundary of the median class. Okay, then capital N, all of you know what is capital N. It is sum of frequency, means what? Total of frequency. Okay, then CF, what is CF? Cumulative frequency. It is the cumulative frequency of the class just preceding to the median class, just preceding to median class. I'll explain in example, don't worry. Okay, see, then F. What is the F? F is the frequency of median class. Frequency of median class. Okay, then what is H? All of you know this. H is what? Class width. How to find the class width? It is the difference between successive lower limit. Okay, now we will see the example. Okay, this is the example. Calculate median for following FD, frequency distribution. Okay, it is asked in exam April 2015, October 21. Okay, see, marks below 20, 21 to 40, 41 to 60, 61 to 80, 81 to 100. Okay, see, below 20 is the open end class. Okay, so we can find the median for open end class, but we can't find the mean for open end class. Okay, see, what are the steps? First step, what is the first step? Obtain the class boundaries. Okay, class boundaries. See, class boundaries. Okay, if they given continuous classes, no need to obtain the class boundaries, but these are not the continuous classes. There is a difference of 1, 40, 41, 60, 61. Okay, so D is 1. Okay, so we have to obtain the class boundaries, and then frequency class boundaries. How to obtain the class boundaries? Subtract 1 from lower limit and add 1 to the upper limit. Subtract 0.5 from lower limit and add 0.5 to the upper limit. Okay, see here, below 20 means 0 to 20. It is 0 to 20. So I write here 0, 20 means add 0.5, 20.5. Similarly, 21, subtract 0.5 from 21. So it is 20.5 to 40.5. Okay, next is 40.5 to 60.5. We already studied this in a data condensation. Okay, next is 80.5 to 100.5. Okay, these are the class boundaries. Next step, what is the next step? Obtain less than cumulative frequency. Okay, what we have to obtain? Less than cumulative frequency. Before that, I write here 1, 9, 32, 16 and 17. Okay, total. Okay, how to obtain the LCF? See, 1, keep as it is. Frequency 1. Here 1 plus 9 is 10. Okay, and again 10 plus 32 is 42. 42 plus 16 is 58. Okay, 58 plus 17 is 65. See, what is the total of this? It is 65. It is also 65. Okay, this is my LCF. Okay, now step 3. What is the step 3? Step 3 is locate the median class, where the median class is the class in which median. Okay, see, median means what? N by 2. N by 2. See how to find 65. N by 2. N by 2 means 65 upon 2. That is what? 32.5th observation. Okay, see, this 32.5th observation equal to or exceed n by 2 for the first time. See, what is this? It is less than n by 2. N by 2 is what? 32.5. So 1 is less than. Clear? Okay. This 10 is also less than. N by 2 is greater. Okay. N by 2 is what? 32.5. See here. Here 42 is greater than 32.5. Okay. First time it is exceed. Okay. First time it is exceed. So 42 greater value. Okay. Than n by 2. N by 2 is what? 32.5. So 42 is greater. So our median class is this one. This is the our median class. Which one? 40.5 to 60.5 is my median class. Okay. Now apply the formula. What is the formula? Formula is, see, median equal to median, sorry, I write it properly, median. Okay, equal to, what is the formula? L plus n by 2 minus CF upon F into H. Okay. Now find out all these things from the median class. Observe the median class. This is my median class. Okay. So what is L? L is the lower boundary of the median class. This is my median class. So lower boundary. What is the lower boundary here? 40.5. So L is what? 40.5. Next, n by 2. N by 2 is what? 32.5. Okay. CF. What is the CF? CF is less than cumulative frequency of the class just preceding the median class. Less than cumulative frequency of the class just preceding the median class. Means it is 10. Okay. Now, F is the frequency of median class. See, this is the F. Median class frequency. This is CF. So it is, F is 32. And what is H? H is the difference between two successive lower limit. What is the difference? Here 20, here 20, here 20. 80 minus 60, 20. So H is 20 here. Okay. Now put all the values in the formula and find out the median. Okay. See, median equal to, put all the values, 40.5 plus 32.5 minus 10 upon 32, F into 20. See, put all values in the calci and find out it. So median is 54.56. Okay, this is my answer. Okay. If any doubt, if any query, please comment me. Okay, we have finished median. Okay, see, What is the median? Median is the central value. Okay. See, there are two cases for median. Okay. First is for ungrouped data, means what? Only observations. If only observations are given, we use these two formula. If but before that, checked whether n is odd or even. Okay. Initially we have to arrange n. Sorry, no. Initially we have to arrange the observations in ascending or descending order. Then count the n. Then apply this formula. Okay. If n is odd, n plus 1 by 2th observation is the median. Okay. See, second, if n is even, n by 2th observation plus n by 2 plus 1th observation divided by 2 is the median. Okay. This is for the ungrouped data, means only observation. This formula for the ungrouped data or only observations are given. Okay. See, second case for the continuous frequency distribution. See, frequency distribution means what? Capital N. Okay. Small l plus capital N by 2 minus CF upon F into H. This is the formula for continuous frequency distribution. Okay. Now we will see the mode. Third point is mode. Okay. Next topic is mode. What is the mode? See, the observation with the maximum frequency is the mode, or most repeated observation is called as the mode. It's very simple. Suppose observations are 2, 5, 3, 5, 3, 1, 7, 5. Okay. See here, most repeated observation is what? 5. So mode of this observation is 5. Okay. In the second case, okay, for individual observations, repeated value is the mode. Okay. For discrete frequency distribution, suppose x is 10, 11, 12, 13, 14, 15. Okay, discrete values. Okay, single values. We call it as a discrete. Fixed value, isolated values, we call it as a discrete. Corresponding frequency 2, 5, 10, 21, 12, 13. See, the observation with the maximum frequency. Okay, the observation with the maximum frequency is 21, but the observation is 13. Okay, observation is 13, so mode is 13 because highest frequency is associated with the 13. So mode is 13. Okay, these are the first case. For individual observation, most repeated observation is called as a mode. For discrete frequency distribution, the observation with the maximum frequency is called as a mode. Okay. Now second case for the continuous frequency distribution. See, second case mode. For mode, second case is continuous frequency distribution. As usual, in a mean, median, we already studied the cases. Data is same. Okay, only methods are different. Okay, for the continuous frequency distribution, as we already know how the classes are. Classes are continuous or discontinuous. Okay, exclusive or inclusive. Okay, if the classes are discontinuous, if there is a difference of 1, then we find the class boundaries. Okay, similarly median में हमने देखा है कि if the difference is 1, then we find the class boundaries. If the classes are continuous, then no need to find the class boundaries. Okay. See, first is what? Obtain the class boundaries. Second is what? Locate the model class. How to locate the model class here? Class with the largest frequency. Okay. Is the our model class. Then apply the formula. What is the formula here? Mode is equal to L plus. L is the lower limit. Okay. Fm minus F1 divided by 2fm minus f1 minus f2 into h. Okay, see here, What is the L? L is the lower boundary of the model class. Okay. FM is the frequency of the model class. F1 is the frequency of pre-model class. F2 is the frequency of post-model class. Okay, into H. H is what? Class width. Okay, we'll see the example. Okay, this is the example. Calculate mode. Daily income, number of persons. See the classes 30 and below, 30 and below, 31 and 60, 61 and 90, 91 and 120. See here 60 and 61. There is a difference of 1. Okay. Now we calculate, we apply the first step. What is the first step of mode? It is obtain the class boundaries. Class boundaries. Okay, class boundaries. I write here boundaries only because जगह नहीं है यहाँ पे. Boundaries. Okay. See how to calculate the boundaries. Below means what? 0. Okay. 30. Below 30. Add 0.5 to upper limit. Below 30. Subtract 0.5 from lower limit. So it is 30.5 to 60.5. Next 60.5 to 90.5. Next 90.5 to 120.5. Next 120.5 to 150.5. Next above 150.5. Okay, these are the class boundaries. Okay, now what is the second step? Second step is locate the model class. Okay, how to locate the model class here? Okay, model class means what? Class with the largest frequency. See, which is the largest frequency here? Largest frequency is 198. So this is my model class. Okay, means this is my model class. This one, my model class, largest frequency. I write here frequency. Okay, what is the frequency here? 22, 198, then 110, then 95, 42, then 33. See, this is my model class. Okay, now apply the formula. What is the formula here? Mode is equal to L plus FM minus F1 divided by 2FM minus F1 minus F2 into H. Find out all values. Okay, L. What is L? L is the lower boundary of model class. This is my model class. Okay. Now lower boundary. What is the lower boundary here? 30.5 is the L. Okay, 30.5. Then FM. What is the FM? FM is the frequency of the model class. So this is my FM 198. Okay. Then F1. What is the F1? F1 is the frequency of pre-model class. Frequency of pre means पीछे का, post means आगे का. Okay. Pre-model class means F1. Ultimately this is F2. Put all values here. F1 is 22. F2 is 110. And H, as usual, H is what? Class width. It is the difference between two successive lower limit. What is the difference here? Difference is 30. Put all values in the formula. Mode is equal to 30.5 plus FM. FM is 198 minus 22 divided by 2 into 198 minus 22 minus 110 into 30. Okay. Put all values in the calculator. Okay, for senior students, calculator is allowed. What is the mode here? 50.5. Okay, this is the method for calculating the mode for continuous frequency distribution. Okay, got it. If any doubt, any query, please comment. Okay, see, this is the mode. First, for ungrouped data, repeated observation is the mode. Second, for discrete observation, observation with the maximum frequency is the mode. For continuous frequency distribution, this is the formula: L plus Fm minus F1 upon 2 Fm minus F1 minus F2 into H. Okay, thank you.